All right, here we go. Unit 1 review. Here's the key. Let's go over a few concepts as we go through it. This one says a function's domain and range. So what you have to identify first of all is what kind of function this is. Is it exponential or is it logarithmic? Kind of easy to decide. If it's logarithmic, it's got that word log in it. Silly, right? Now, if you remember, I told you the easiest thing about exponential functions is its domain, because it's all real numbers. That capital R, remember, stands for all real numbers. Numbers. We got some numbers up here. Numbers. All right, now let's talk about range. Range had to do with y and the asymptote. Now it was either greater than or less than the asymptote. So let's identify the asymptote. Remember that asymptote is just a wall. So if you're following the function, walking down, thump, there it is, there's the wall. This right here is when y equals 0, right? The coordinates right there are 0, 0. So this line is just y equals 0. So my r for this function is going to have y and 0. And then you decide which one it is of these as looking where the function's at. Here's my line, right? There's my asymptote. And if you look where the function's at, the function is up here above that line, which means y is greater than that. If it had been below it, then we would have said that it was less than. So that's your answer right there. Okay, next one. This one says state the function's domain and range. Again, it's exponential, which means the domain automatically all real numbers. Okay, first we have to find the asymptote before we can say the range. Looking at it, here's the function down here. So I'm riding along, thunk. There's my wall. So again, that line right there is your asymptote. And that is when y equals 0. So the range is y and 0, and then it's either going to be less than or greater than. Remember, greater than would be if we went up. Less than would mean that we went down or below the asymptote, which means the less than. Domain and range is all about the picture. There we go. Always all about the picture. Now you can also think of it as the proper form of it. If you're not sure, then graph it. So this one right here, it's log. So when the domain of an exponential is all real numbers, with logs, they switch. So the range of this guy is going to be all real numbers. But the domain is now going to be x and an asymptote. This time it's a vertical one because it's log. I'll show you the picture in just a sec. And then again, it's going to be a greater than or less than, based off of whether the graph is on the left side or the right side. Let's look at the picture. Okay, so I pulled the picture, the graph up on Desmos. Remember, it's just a matter of typing it in, just exactly as it was. All I did was log parentheses x minus 2 parentheses plus 3. If you look right here, if I were walking along the function, walking, here's where my wall happens. This time the wall is a line up and down, and it's at 2. Now granted, it's an x equals 2, and that's because we're now talking about a vertical asymptote. since my asymptote is at x equals 2 this time, my domain is going to be x and 2. Now, looking at the graph, is the graph on the right side? Oops, here's my line. Is the graph to the right of that line? Is it on the right side? Imagine it being split, or on the left side? It's on the right side. Now think about it, we're talking about x's. If I move to the right, are my x's getting bigger or smaller? They're getting bigger, which means it's going to be greater than. This means it's on the right side of the asymptote. All right. Oh, that was just the domain. Silly me. So down here is the one that asks for the range. Again, the range is the opposite of an exponential function. So the range, this guy gets to be all real numbers. All right, this one says, what is the asymptote of the function y equals x minus 1 plus 3? Now again, you can plug it into the graph and identify where it's at, or you can also use your cheat sheet. So let's pull that up. Okay, so I'm going to show you both ways of looking at this. We're going to look at the graph and then also the cheat sheet I have that will help you with this. So over here in Desmos, let me show you how to type it in because there's some different things you have to do when there's more than just a number or variable up in the power. So you would hit the letter E and then do the power, shift 6, right? Now you've got to do a parentheses because you've got to do an x minus 1 up in the parentheses. Watch what happens if I don't. So I'm up in the power, I hit x minus 1. It automatically bumps that minus 1 down outside of the power, and we need it to be inside. And then hit the arrow and do plus 3. So that parentheses is how you tell it there's more than one thing up there. Okay, here we go looking at the graph. You can see that as we're writing down the function, going, bam, we hit a wall right here at 3. That becomes your asymptote. So for this guy, the asymptote is at y, because it's exponential, equals 3. Now the other way of telling is, if you remember, we had this cheat sheet right here. The asymptote is actually that number on the end that's being added or subtracted. So right here, if you look at the equation, that 3 right there, because it's plus 3, it's going to be the asymptote. It moved it up 3, so that would be the asymptote. If it was subtract 3, then it would be y equals negative 3. So the sign goes with it. This is actually the same thing down here, right? Here's my asymptote, and if I graphed it, then it would be at y equals negative 9. But this guy right here, this plus or minus d, is the easiest way to do it. Okay, this one says write the equation in log form. The formula is, if you have b to the x equals y, then you change it by writing the word log. You're going to move this guy, the base, to the base for the log, right? This big guy becomes the little guy. And then these ones switch. So y was on the right side of the equation. Now he gets to be on the left, and x gets to be on the right. All right, so here, this is our base. And these two are going to switch. So I'm going to write the word log. We'll put that base, whoops, He just jumped right down. Just rewrite it. That guy just kind of went boop. See ya. Okay, write the word log. And then this base guy here becomes the base for the log. Whoops, not B, it's a 6. Why isn't it erasing? Distraction. Okay, a 6 goes there. And then the 4 and the 1296 swap places. So the 1296 is going to be over here, and the 4 gets to be on the other side. Okay, same thing on this next one. Rewrite it. So we've got to determine what our base is. And these two are going to swap sides. So write the word log. Put your baby base in and switch. 1 over 25, that equals -2. Right, next one. Identify the base. Write the word log. Fill in the baby base. Swap places. Okay, this next one says to write a rule for G that represents the indicated transformations. Transformations is the important part there. It's called a G just because I'm going to write it out as G of X. All right, G of X is a transformation of that. So that's my original. And I have to make 2 changes to it. I have to do a reflection in the x-axis, and then I'm also going to do a 4 units right change. So this is where this transformation sheet comes in handy right here. If you read through it, if I want to do a reflection, if you look at this guy right here, it says if this number is negative, then there's a reflection over the x-axis. So I'm going to use that idea backwards and say, well, if I need a reflection over the x-axis, that means there needs to be a negative out in front. Okay, let's look back at our sheet for the other one. We need to go 4 units right. That's right here at the top. It says right. And underneath it, it says subtract. And if you see this example right here, it's, it says add or subtract in the power, sorry. You can see that that -1, that's up in the power with the x. So if we say 4 units right, then up here in the power, I need to subtract 4. So basically, I'm going to make this look like one of these on here and make all the changes so that it looks similar to that. So that thing's mostly for transformations, but it can also help you with the range. Okay, now we have a log and we need to go to exponential form. So same idea, log with a little base b. Okay, just switch it over to exponential. You're going to find the base, the b, the base for the power. He becomes big again. And then these guys right here switch. So it's going to be equals, or sorry, with a power of x, and that equals y. So base is 32, switching 3/5 up in the power. It doesn't matter if it's a fraction. It's still just the exact same thing.